Here's another quick example. Let's plot the force acting on some geometry, and it's supporting a mass of a fluid. We know the density of the fluid is 62 pound mass per cubic foot. We know that there's a volume of 2 cubic feet of this fluid, and the weight is equal to the mass of the fluid times gravity. And I've got this conversion function in here because we're working in English units. So for this some particular problem, the force is equal to the weight of the fluid divided by cosine of theta. Let's start by making a graph of that. I'll insert a new parametric table, and let's say 90 different runs, and I want f in my graph, and I want theta in my graph. We'll let theta vary. And see in my parametric table, let's let theta range from 0 degrees up to 89 degrees. Now click OK. This fills out values for theta. If I run this, it gives me values of f for every value of theta. To graph this, let's do new plot window, and in my x-axis I want theta, my y-axis I want f, and up here let's add a legend item, but what I'm not going to click is automatic update because I want to run it for a couple of different fluids with different densities. So I'm not going to auto-update this graph. So we'll include a legend item, and let's just use a thick line, and I click OK on this guy, and here's my graph with theta ranging from 0 to 89 degrees. Let's set the range on the graph from 0 to 90 degrees. 15-degree intervals seem to make it look fairly nice. So here's my force with theta. Let's say the text is F for rho equal to 62 pound mass per foot cubed. So I'll click OK on here. So here's my first plot. Let's overlay another plot in which the density of the fluid, instead of 62, is now a smaller density, let's say 20 pounds per cubic foot. So I'll come back to my parametric table here, and I'll rerun it, and you'll note that the forces will change now because we're going to run it with a smaller density. So I'll click play on this. These forces are now smaller. Let's add these to this graph. So I haven't clicked automatic update. These values didn't change. So let's overlay. I'll click up here, overlay plot, and my x-axis is theta, my y-axis is f. I'm going to plot x on the lower x scale, the left y scale. Let's add another legend item. Let's not use any symbols. We'll make it blue, and I click OK on here, and here's my force in the other condition, and I'll change this label. And I'll change it to be consistent with the first label. Let's do another one now where we have a really large density, let's say 200 pounds per cubic foot. Go to my parametric table, rerun these, I get new values for f. I come back to my graph. Let's overlay this one on my axis theta again, y is f. Let's add another legend item. We'll get rid of the symbols. This one will be in red. So I click OK. Here's my new one in red, and I'll update the label to make it consistent with the other two. So this is a quick way to overlay all of these graphs. So if I wanted to make the graph look more square, I can drag it, and if I was going to turn it in, I would go File, Print, and let's show the formatted equations, not the regular ones. We could show the solution if we want. Let's not show the tables because they're huge, and let's show the plots. Once I print it, here are my formatted equations. They look fairly nice. For example, my density rho, it uses the Greek letter rho. Here's gravity, my conversion factors. Here's my formula, the weight divided by the cosine of theta. And this shows the solutions for the last run in the parametric table where theta is equal to 89 degrees and my density. And it shows the plot that we're after. And this is something you could turn in for your homework.